Hi, welcome back. Let's continue with the review. In example number 10, I recognize right away that we're solving a quadratic equation, okay? So we're solving a quadratic equation in this form. Ax squared plus bx plus c is equal to 0. This is referred to as a quadratic equation in standard form. And there's a few advantages as to why we want to write a quadratic equation in standard form. For one, we can try to factor it. Okay. It feels as if factoring is the easiest thing to do when it comes to solving quadratic equations. Okay. So let's see if this thing factors. If it doesn't, we'll use another method. So let's see. It always begins by multiplying a times c. So 1 times 12 is equal to 12. I list all the factors of 12. The easiest way I could think of this is what are the numbers that multiply to 12? Okay. If it factors, one of these combinations is going to combine to -8 by adding or subtracting, okay? So the way to do that in this case will be to do -2 and -6. The other ones won't do that, okay? So I'm actually going to move a little quicker through this example for a few reasons. A is equal to 1. Therefore, if I find this right combination of numbers that multiply to 12 and combine to b, this can easily be factored into the following. V minus 2, V minus 6 is equal to 0. What to do from there? Well, from there, V minus 2 is equal to 0, or V minus 6 is equal to 0. Moving quickly through this, we get that V is equal to 2. Moving quickly through this, we get that V is equal to 6. So the solution set for this example is two unique solutions, and those two unique solutions are 2 and 6. All right. Moving on to the next example, or jumping into the next example. The next example is not in standard form, because if it is in standard form, all of the terms are in one side of the equal sign, and on the other side is 0. So to make this quadratic equation in standard form, let's add 7 w's to both sides. So we get 2w squared plus 7w plus 3 is equal to 0. Let's try to factor it and see what happens. A, in this case, is 6. 1 times 6, 2 times 3. That's it. How can we possibly get a 7? We can get a 7 by adding 1 and 6. But what is different about this example from the previous example? The fact that A is not equal to 1. So let me highlight that because that is important. That is important. So I won't be able to make conclusions as quickly as I did here. What do I need to do instead? We need to expand the middle term using these numbers. Notice that is the same equation. It is still 2w squared. It is also 7w, but not just any numbers that add up to 7. Very specific numbers, okay? And we found that, and we found them by multiplying A with C. Alrighty then, moving on here, I use the grouping method, so something that looks like this, because I have a really good feeling that this is going to work out. Out of the first group, we can factor a w, leaving us with 2w plus 1. I'm going to go ahead and copy and paste that factor. And then I'm going to say that I'm going to need a plus 3 so that we can get a 6w plus 3. What happens now? There is a 2w plus 1 that is common, and then a w plus 3. What are the solutions? 2w plus 1 equals 0, or w plus 3 is equal to 0. Moving quickly through this, we get that 2w is equal to negative 1. Dividing by 2, we get w is equal to negative 1/2. Moving quickly through this, we get that w is equal to negative 3. Okay? So clearly, we are going to be challenged with solving some quadratic equations. And notice that in this case, we're being challenged with what happens when a is equal to 1. In the next example, it wasn't in standard form. We wrote it in standard form, and the factoring was a little bit more involved. Let's look at this example on number 12. We have a quantity that is square. X plus 7 is square, minus 12 is equal to 0. Okay, it's not really in standard form. It's not really in standard form. Let's revisit what that looks like. This is a quadratic equation in standard form. This doesn't quite look like that. Can we make it look like that? Sure, we can, but I think it will take a little bit more time. Instead, I challenge you, why don't we use what we know about operations? We know that adding and subtracting are opposites from one another. We know that multiplying and dividing, they're opposite operations. So what is the opposite operation of squaring? You're right. It is to take the square root. Okay, so let's see. Let's pick a different color so we can show that. So if we take the square root out of both sides, then this quantity, oops, I don't need the parentheses anymore because that's the whole idea. But the square and the square root cancel each other out. And so there is no need for parentheses. However, on the other side, we do need to be cautious because there's going to be a positive square root of 12, and there's also going to be a negative square root of 12. Okay, that's kind of like the little detail that we need to be careful with there. Okay, x plus 7 is equal to, this is the square root of 4 times the square root of 3, which is 2 square root of 3. Okay, revisit simplifying radical expressions as needed. Okay, and then to get the job done here, we get x is equal to negative 7 plus 2 square root of 3. These numbers do not combine together because this one is completely rational and this one is completely irrational. So there's no way for them to mix together. We can only write them side by side. So now that we did this, I think I'm going to move a little quicker through this example. That will be negative 7 minus 2 square root of 3. And so therefore the solution set, I'm going to write it as negative 7 plus or minus 2 square root of 3. Okay. Alrighty then. That's that example. Moving on to 14. All right. It says, it's kind of telling us from the very get-go. Oh, wait. I'm skipping 13. I was jumping into 14. Okay. Let me not do that. Let me go ahead and take care of this. And it says to use the quadratic formula. All right. So what am I looking out for on your work, on your paper? That when you solve this particular example, if you're challenged with something like this, with these exact words on the exam, that we use the quadratic formula. So what does it look like? Well, the quadratic formula is this. Well, first of all, let me start here. If it is if that quadratic equation is in standard form, solutions to that equation will be of the following: negative b plus or minus the square root of b squared minus 4ac, everything divided by 2 times a. That was my best attempt at singing the quadratic formula, okay? X is equal to the negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. And hopefully I'll get a Grammy for that. But let's go ahead and use the quadratic formula in this example, okay? Luckily, it's already in standard form. This is A, that is B, and this is C. And so the quadratic formula really is a game of plugging in the right numbers. There is a negative to begin with, and then there is B. Plus or minus. Hopefully we won't spill into this stuff here. Okay, we got negative 7. Oops. Doesn't look like negative 7. Let's try that again. Negative 7 quantity square minus 4 times A times C divided by 2A. Let's clean up. That will be a positive 7 plus or minus. I'm about to use my scientific calculator here in a minute because I can't multiply that much. So I am using my scientific calculator. And I'm going to multiply, which I'm trying to just kind of make a little bit of time so I can go ahead and multiply. So we have, I should just possibly just stop this. Let me see if I can just do that real quick. Okay, so after using the scientific calculator, I got 89. So while I was paused, I also said, is there a way that I can simplify 89 or the square root of 89? And I'm not able to, okay? So therefore, 7 plus the square root of 89. Something tells me, okay, yes, we're good. Over 4, and the other one is 7 minus the square root of 89 over 4. Okay, there it is. I panicked a little bit because I was expecting complex solutions, but that is the next example. All right, let's see what we got going on here. They're already telling us that we're going to find complex solutions. So I am going to jump right into the quadratic formula because if they're saying this, it's because it doesn't factor. So let's jump right into the quadratic formula. Negative, and then b. Plus or minus the square root of negative 4 squared minus 4 times a times c, everything divided by 2a. Okay, so let's delete this out of the way. Let's clean this up. Negative and a negative becomes positive. Positive, negative, the square root. I am going to use my scientific calculator, so be ready for that. So I am pausing while I use. So after using the scientific calculator, I got negative 44. Okay. Well, what is that? Well, let's see. Let's just take one thing at a time here. This negative comes out as the I. Okay, so let's do that first. 4 plus or minus I, the square root of 44. Okay, now we took care of that first. Okay, we took care of that first. Let's take care of the square root of 44. Okay, 44 is 4 times 11. Therefore, I don't know if I've done this before, but therefore, the square root of 44 is the square root of 4 times the square root of 11, which is 2 times the square root of 11. So let's put it all together. This is 4 plus or minus let me write it like this because I don't want to confuse anybody. Let me write it like this. 2 square root of 11 and then I at the very end, everything divided by 6. I can make this better by saying 4 over 6 plus or minus 2 over 6 square root of 11 I. I can make that better by saying 2 over 3 plus or minus 1 over 3 square root of 11 I. I'm going to leave it alone and I'm going to move on to the next example, okay? All right. What should I say? Well, this is the real, this is the imaginary part. They're separate. So, there it is. Maybe I can write it a little cleaner here. So, x is equal to 2 divided by 3, a positive and a negative, 1 over 3 square root of 11, and then I'm going to put on the I at the end. And I'm going to leave it alone, and now move on to number 15. It's an application problem. Oh, holy frijoles. The length of a rectangle is 1 meter more than twice the width, and the area is 45 meters squared. Find the dimension of this rectangle. Okay, let's see what kind of jelly jam we get ourselves into here. It is a rectangle. So the rectangle has, I'm going to label this as the length, as this to be the width. The example said that the length is 1 meter more than twice the width. That translates to 2w plus 1. It also says that the area is 45. Well, how do we find the area of a rectangle? You are right. Length times width. So in this case, length is in terms of W. So the area, which is 45, is equal to, and let me write it like so. W, the width, times the length, 2W plus 1. So again, this is the same as just, right? So W times the length. And now, well, it seems like I need to solve this, so I need to distribute and see what kind of mess we get we got 2W squared. Oh, we're solving a quadratic equation. So let's write it in standard form. Okay. So 2W squared plus W minus 45 is equal to 0. Okay. Let's see if we can factor it. A times C is negative 90. Numbers that multiply to 90. I'm gonna go simple with this. 9 and 10. How do we get a 1? 10 minus 9 will be 1. And also check, triple check. Negative 9 times 10 is 90. So, as previously mentioned, since A is not 1, we got to take the long way to this example. It's just the way it is, but it gives us good practice, especially for those of us that need the practice on this particular skill of factoring. I know it could hinder and be also a barrier, but also it gives us practice. So it's a good thing. It's a good thing. Let's not see it as a bad thing. Let's see it as a good thing. Factor out a W. Here I'm going to copy and paste 2W minus 9. But right up front here, I'm going to put a 5. Why did you put a 5, Mr. V? Why did you put a 5? Because 2 times 5 will be 10. And because 5 times negative 9 will be 45. What do you do after that? Okay, I got you. 2w minus 9 times w plus 5 is equal to 0. What does that mean? That means that 2w minus 9 is equal to 0, or that w plus 5 is equal to 0. Moving quickly here, we get 9 halves, or 4.5. And here we get, check this out, negative 5. And so one of these answers cannot be it. And I'm going to tell you which one is not it. It's not this one. That is saying that there is a dimension that measures negative 5 meters. When have we ever went to the store to buy a piece of wood and asked the Home Depot guy, hey, can I get a negative 5-meter piece of wood? Never, never. So therefore, rejected. Okay. What do we get out of this? Well, it means that the width is 4.5 and the length must be equal to, well, let's see. 45 is equal to 4.5 times L, divide by 4.5, and we get that L is equal to 10. I just try to move a little quicker now, okay? So the length is equal to 10. Alrighty, then that's the application problem, especially when it comes to application problems. There could be a very, very reasonable reason as to why one of the answers has to be rejected. All right, let's go ahead and continue here, and let's take care of 16 and 17, and we'll call that the end of this section, and then we'll move on to the last video, okay? So let's go ahead and do this. They want us to solve for m. Oh man, these fractions are always in here. But let me write it like so that is nice and clear. Let me write it like so. I just want to write it like so. Give me 1 second here. Okay, give me 1 second. That will be n over 1. What is the least common multiple? I have no idea. So the easiest thing to do is just to say multiply, and we get km to be the least common multiple. Okay, I just multiply the denominators. That's sometimes the easiest way to get a common multiple. So what does that mean? It means that we need to multiply this by m. We need to multiply this by m, this by km, this by km, this by k, and that by k. That guarantees that every denominator has km. What happens now? 5m is equal to kmn minus 6k. We're solving for m, so everything divided by 5. M is equal to, oh, wait a minute. Holy frijoles, I didn't see that. Too fast. This also has an M, and the reason why I didn't see it is because I'm not writing the same M's. So let me write it as lowercase m. Let me put the M's on the same side, or the terms that have M's on the same side. And now factor the M, okay, like so. And then I'm just going to move quickly through this example because it's not the nicest of them all. So I'm going to finish with that. I factor and then I multiply. There it is. Okay. Not my best job at that. But hopefully I can redeem myself on the other example, because we're looking for R. And I mentioned earlier that some operations are opposites of one another. Adding subtracting, multiplying, dividing, squaring, square root. So in this case, since we're trying to get to that r, we need to get rid of the square root. So we get w squared is equal to r. Let me write it exactly like it is on there, divided by 2. To get this out of here, which is dividing, we multiply by 2. So r is equal to 2 times w squared. I like that example better than the previous one. The previous one is very involved. It's a really good skill, but I wouldn't let it consume me if I don't know how to do that, okay? All right, it's not the reason why you're not being successful in this class, okay? There's a lot of other things that are more important, and I will probably say, look at what we did in example 15. Look at what we did in example 14. Look at what we did in example 13. Those are important skills that we need throughout this class. Look at what we did in 12. Look at what we did in 11. And look at what we did in 10. Okay, those are really, really important skills that we need to move forward in this class. Okay, so I'm going to try this one more time. I want you to go ahead and click on the next video right here, all right, so that you can see the end of the review. I'll see you there.